Hello everyone, in this presentation we are going to understand how to interface a 7 segment display for both up count as well as down count. If you observe carefully, this 7 segment display is displaying the numbers from 0 to 9, and then after 9 it is counting down from 9 to 0. So up count from 0 to 9 and then down count from 9 to 0. So how to interface a 7 segment display? To increment the count from 0 to 9 and then decrement the count from 9 to 0. That is what we are going to experiment today, right now in this presentation. Here you see the count starts from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and then 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Then continuously it repeats. So how to do this? As we know very well, port 0 of this 8051 microcontroller is connected to the multiplexer 7 segment display here, and then all the 4 segments selection can be done with the help of 4 transistors. So you have given 5 voltage to the base of the transistor. So transistor acts as a switch. So when the base is 1, it acts as a closed switch. So all the common cathode 7 segment displays are grounded. So all the 4 7 segments are working. So if I remove one 5 volt supply, one 7 segment will get disappeared. So again, if I am giving this base to 5 volts, means that 7 segment is glowing. So by this way we can able to enable the corresponding 7 segment as per the requirement. Now I am just interconnecting this 7 segment display through this connector which is displaying the numbers from this. So if you go to the code, here you can see it's very interesting, because it has to count only the 9 counts from 0 to 9, that is, it has to count only the 10 counts. So we have used the for loop. So this is very important thing we have to note down. So there is a for loop which starts from 0 to 9. That means I equal to 0, I less than or equal to 9, I plus plus means less than or equal to means what, up to 9. So 0 to 9 means, so this for loop will execute 10 times. So as usual, as we discussed, when we want to interface a 7 segment display, we need to do 2 code conversion. One is binary to BCD code conversion. Binary to BCD code conversion is happening by this, and BCD to 7 segment code conversion is happening here. So C %10 means the binary value will be converted to decimal value, and the decimal value is stored in the variable ones. And so this one dimensional array, as we see here, this one dimensional array is the 7 segment code for the numbers from 0 to 9. So for example, 3F is the 7 segment code for displaying 0, and 67, as you see here, 0x67 is the hexadecimal code for displaying 9. So port 0 equal to A of ones. If ones equal to 0 means A of 0 is 3F. So when you send 3F, 7 segment will display 0, as we know very well. So we are incrementing the count by C equal to C plus 1 with a constant delay of some 50,000. So this for loop will execute 10 times. So initially the C variable is given the value as 0. So before going into this for loop, C variable will become 0. Then after displaying 0 in port 0, C variable will increment. So C variable will become 1. So then 1 will get displayed, then 2 will get displayed, then 3 will get displayed, then finally 9 will get displayed. So because the for loop is written up to 9. So after displaying 9, so it is coming out from the for loop, and then again we are giving the values 9 for the C variable, and then we are running another for loop. So this for loop is again running for another 10 times, where the C value 9 is getting displayed first. So P naught equal to 9, that is C equal to 9 means the ones means what, the one variable will have binary to BCD code converted value, and then P naught equal to A of ones means BCD to 7 segment code converted value is displayed in port 0, and then after some delay 9 will be decremented to 8, C equal to C minus 1. So then this for loop will execute 10 times. So 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, up to 0 it will run, and then it will go to this for loop by making C as 0. So all are written inside the while loop. So 0 to 9, as well as 9 to 0 is continuously happening in this 7 segment display, as you see here. So if you look at this, if you want to change the delay from 50,000, so if you observe carefully now, so here it is counting in some format. Now if I changing the delay, means delay from 50,000 to, say for example I am changing it from 30,000, 50,000 to 30,000 means, so the delay value is decreased, so the counting rate will increase, that you can experience it here after changing this. And then simply we are building the code, and then through Nuvoton we are downloading this code to this kit using UART. So while downloading, we have to press the reset button. So it is getting downloaded. Once downloaded, when you press, means you are able to see. So now it is counting little bit faster. So 1 2 3 4 5 6 7 8 9 8 7 6 5 4 3 2 1 0. This is how 7 segment display can be used for displaying the numbers from 0 to 9 as well as 9 to 0. This can be for acceleration, this can be for deceleration, anything you can use it. That is how it works. Thank you very much.